Okay, so let's get to the trick, right? How do you convert between them? And to convert them, this is my main trick, is to remember this particular identity, right? This is not just equal, these are identical. This is an identity, okay? All of them are. Okay, 30 degrees is identical to pi over 6 radians, okay? Or pi over 6. What does that mean is you can take that and you can divide 180 degrees to the other side. So you have 1 is equals to pi over 180 degrees, right? So you can remember that. That is literally 1. Okay, so if someone asks you, so here's the trick, right? To convert between them, someone asks you, what's 37 degrees? Degrees in radians. So you can now say, well, I want to get rid of the degrees. What do I need to do? Well, I want to divide by something that has a degree. Well, I can divide by anything that has a degree, but this is particularly nice because 180 degrees is pi, okay? But I cannot just write the equal sign like that. I cannot just say 37 degrees is 37 degrees divided by 180 degrees. That I'm changing it, right? This is not equal to this, but I can put a pi here, right? Because this is 1, okay? This is 1. So I'm allowed to multiply 1 as much time as I like, but now I just want to get rid of the units and we can cancel that unit. And what now is left is 37 times pi divided by 180, right? So in the calculator, you will basically plug this in the calculator and whatever the number is, which I think I've done in advance, you can double check if I got it right. I think it's 0.65. I don't have it right here with me, but I think it's 0.65. Someone can correct me in the comments or later on if this is not. Okay, so if you like, you can put in radians. You can say, hey, I'm not comfortable, and at the beginning, if you're not comfortable, it's fine. You can put radians. So you can put you can put rad or radians, whatever. Then this is pi radians divided by that. This all works out as well. So you can keep the radians on top, and you have 0.65 radians, whatever, like that. Okay. So that's an easy way to do it. If you want to go the other way around, if someone say, can you tell me what 0.65 radians is, right? So what is in degrees. So now, so if you're not comfortable, you can start with writing down radians, and you would like to say, hey, I would like to get rid of the radians. So I want to divide by something that has the units of radians. Yeah, I don't write radians as much as you can see. So if I divide by pi radians, so now the radians will cancel out, but I cannot just divide by something. I need to multiply it by something, and this is okay because this factor is 1, right? So what I need to plug in my calculator is 0.65 times 180 divided by pi, and whatever that is, put the degrees at the end, and that would be the answer. So you plug this in the calculator. If I've done that one correctly, this one should come out as 37, and there's a degree on top. Okay, so that's my way of converting between one through another. That's exactly what textbooks will tell you to do, to multiply by pi, divide by 180. Okay, finally, let's talk about why we use radians at all. Okay, so I just told you 360 degrees is very arbitrary. Okay, so let's forget about 360 degrees. Let's rethink it. I want a way to measure angle. I want to measure angle. How do I measure angles? Well, what's an angle? Well, angle is like this, right? That's an angle. Okay, what's a good way to measure angle? Well, I want a quantity, I want a measurement that if I make this larger, that number will increase. And if I make this smaller, that number will decrease. So what's a good way to do that is, well, let's join this up, right? So if this is like a rule, if this is like a stick that I can sort of tilt from here to here, right? If I start tilting more and more, I increase the angle, then this length over here will increase. Well, that would, so why don't I just measure the length, like the distance, right? The length of this path and use that as an angle. That's a great idea, okay? Except for, there's a small trouble. Let's say this is the radius, right? As you move through here. This length depends on what the radius is, right? Because if I double the length, if I double the radius, then I have a larger length over here, right? So this is mathematics call this an arc length. It's the length of the arc that is formed, right? It's the arc that's formed by this pizza slice. So it would be good if I just measure this with length in terms of meters, right? So I'm going to use meters. If it's 3 centimeters or 3 kilometers, whatever, that's the angle. That would be a good idea. That's mathematically motivated. I don't need to invent a special number like 360 or whoever it comes up with. Right? That's just the direct way to measure the angle. Except for the problem, it depends on the radius, right? If you make a longer radius, then I'll have a longer arc length, but the angle, it subtends, is the same. Okay, so this angle, right? Both of these lengths is sort of spanned or radiated out by this angle, but it has different length. So in fact, how much larger is this if I double the radius? If I double the radius, here's a trick, right? So let me draw a parallel line from here, right? It's not very parallel, right? So if I draw a parallel line to this, then this is the same angle as this one, because that's another straight line, right? Draw a parallel line, right? So then that means this is L. And if I draw a parallel line here, right, take this R, move it down here, theta, right? So that's another L, right? So if I draw a parallel line like this, and draw a parallel line like this, so this is basically I shifted down over here. So you have L over here. So this distance is 2L if this distance is 2R. So what does that mean? If I increase the radius by a factor of 2, I increase the arc length by a factor of 2. So they seem to be proportional. So here's an idea. What if I define this by the length over R? What that means is I'm going to choose a special number for R, and the number is 1. If R is 1, so if R equals to 1, theta equals to L. So that's my special radius. So that, if some of you recognize, that's the unit circle, right? So if I pick a unit circle, i.e. a circle with 1 unit, then I'm in great hands. If I pick a circle that has radius with 1 unit, whatever that length is, that's the angle immediately, okay? So if you want to know this angle, just measure this length. If it's 0.65, that means this angle, I don't need to convert that to degrees. I immediately know that. That's 0.65 radians. That's what radians is. It's the arc length. So radians, in some sense, if I write it in words, radians is the arc length when the radius is 1. Okay, so if the radius is 1, radians is the arc length. Okay, now you start to see why this word comes about. It's because it has strong relation to what is a radius, to the idea of radius. And now you see if but we don't always have nice circles, nice unit circles. What if this is 2 units? Well, no fear, because the arc length is just r theta, right? So if I can rearrange this, and you can see that if the radius is 1, all right, good, the arc length is the angle. But if the radius is 2, that's fine. If the radius is 2, the same angle you give me, you just need to double it. So what I'm saying is, right, so if I use things in radians and I say, hey, this is radians is 0.65. What does that mean? It means if this length is 1, this length is 0.65. And then you might ask, well, I don't always have a radius that's 1. Maybe I have a radius that's 2. You'll say, well, no fear. Take 2 and multiply by the angle. Okay, so it just scales. So it basically, if you use radians, this is a formula. You can basically just find that the arc length is just the radius times the angle. This formula does not work in degrees. It only works in radians. Okay, and you can treat this as a definition of radians. And so this brings us to a final point about the units. You see, what is the units of radians? If this is measured in radians, right, 0.65, it's really no units. It's a ratio of lengths. If you measure this in meters, this is in meters as well, right? The standard units of length is in meters. So meters over meters, it's unitless. So radius has no, radians is basically not really there's no unit. It's just a concept. So you measure the angle. In summary, it's a way to measure the angle by the ratio of the arc length with the radius. Okay? You take this, divide by this, and you get this. Okay. Now, let's address the final thing is, what about a full circle? What is the angle for a full circle? So this is a full circle, right? Well, then I need to move through a full circle, right? So this is the whole angle, right? In other words, let's write it over here. So equals to L over R. If I go like full circle, I want the theta for the full circle. I need the arc length of the full circle divided by the radius. What's the arc length of a full circle? What's the arc length of a full circle? The full circle is 2 pi r. It's circumference. That's this part, right? So if I take that part, that's the arc length. If I take that as theta, then that's the arc length. If I take the whole thing as theta, then that's the whole arc length, which is just 2 pi r divided by r. It's 2 pi. So you see, theta for a full circle is 2 pi. Okay, so that's where the 2 pi comes from. It is in some sense God-given. It's the fact about circles. Circles have full, the whole length is 2 pi r. That is proven by the Greeks. It's just a mathematical fact. So 2 pi is a special number. Whereas 360, not really that special other than human convenience. So that's why it's mathematically a lot of facts, a lot of formulas, such as this one, and flipping it around, right? R theta. These two and a lot of math formulas are so much more convenient in radians. And if you want to calculate the arc length in degrees, you need to take this and multiply by this, or the other way around. So the other way around. If you measure this in degrees, then you will have a awkward factor like this in front of you, and you will get nice formulas like this. Okay, all right, so that's a quick intro or review, I should say, about radians, and we'll continue with circular motions.